To start chapter 6, I'm going to give you guys just a little warning, but don't be scared, and then a request out of you guys. The warning would be chapter 6 is generally considered the hardest out of all of the chapters, all of the units in pre-calculus 30. It's very theoretical math that does eventually have a big purpose. You don't see it right away in this chapter. It's stuff that you wouldn't have seen coming. It doesn't feel often like a traditional math lesson. Now, the request I'm going to have of you guys is please open your textbooks up immediately to page 296. Just pause the video, go to that page, because you will need to see a list of some of the identities that we're going to take a look at. So just again, pause the video, have your textbook ready at page 296, and then you're going to see what are called the 8 fundamental identities. Now, what happens, first of all, in this lesson is you need to know what is a trig identity. So in number 1 in the PDF notes, you kind of see a definition where it says a trig identity is an equation where both sides have the same value for all permissible values. And you're like, okay, what does that mean? First of all, okay, I'm going to write down the very first one, and then I'll only do one and you guys can look at the other ones. This feels like something that you know. You might be like, why do they have to give this a fancy name of called a trig identity? We know this already. We know that the reciprocal to sine is called cosecant. In the last day of chapter 5, we even take a look at the graph of cosecant. So we know it quite well. You could also, if you wanted to, say that sine is 1 over cosecant. We'll use that at some point in chapter 6 as well. They're called reciprocals. And then again, it doesn't really make sense in the definition. What also we have, maybe I will write one more down, we have that secant is the reciprocal to cosine. Because we have an equal to sign, okay, this is saying you could put a value on this side for x, put the same value here, and it will be equal. And you're like, okay, yeah, I don't need anything fancy for that. But when you were looking at page 296, these are again called the reciprocal identities, and you have tangent equals 1 over cotangent or vice versa. The next group, okay, that I would write down would be where you start to be like, okay, yep, I gotcha. This is where one side is technically equal to the other. So what we're going to write down is the next identity. This is called the quotient identities, that tangent of x is equal to sine over cosine. Now, you might be like, well, am I just making this up? Or is a previous very, very smart person just making this up? No, this has been proven as true. And you could even test it. You could pick your favorite number. Let's say your favorite number was 7. And you put a 7 in for all 3 of these x's. You type in tangent of 7 in your calculator and write down the answer. Well, if you go to sine of 7 divided by cosine of 7 hit equals, it's the exact same answer. And that will happen no matter what. Okay, no matter what you put in for x, it will be the same. And then you're like, oh, okay, so a trig identity, these are all trig identities, is where you can put in a value and it will be the same on both sides. It's equal. Okay, so maybe the opening line still seems like they're making it sound too fancy or harder than it is, but it is the most correct mathematical way to say it. And then at that spot, then you realize if tangent and cotangent are reciprocals, if tangent is accepted to be sine over cosine, cotangent will be cosine over sine. And it's called an identity. And it's again called the quotient identities. Now, in the final group, okay, and I'll just squeeze it in down here. I'll just write one down. And this must have taken them a long time. There is something called the Pythagorean identities. The name of it is because these guys resemble Pythagoras. A squared plus b squared equals c squared. This would be probably the most used one, but then there's 2 more. 1 plus tan squared equals secant squared, and cotangent squared plus 1 equals cosecant squared. They are called the Pythagorean identities, and they are true. And there's a really neat proof in the PDF version of the notes. And I think it's worthwhile even just saying it, because then again, the opening statement of what is an identity really makes sense. And so it goes like this. What I wrote down was cosine squared or sine squared. First, that order doesn't matter. I have it opposite in the notes. It's fine either way. And let's say we chose 30 degrees. Now, you have to remember, when you are squaring something, it really means the whole thing squared. Every major senior textbook in the world writes a square like this. It's just a compact, neat way to do it. And then, let's say we chose an easy angle, and it would work for any angle, 30. Here's what would happen. You could type in cosine of 30 in your calculator, hit equals, and square it. type in sine of 30, hit equals and square it. And when you add it, it'll be 1. And you might be like, well, that's just magic in the calculator. You can even do it with the unit circle. Sine of 30 might be really easy in the unit circle. It is a half. Cosine of 30, if you actually took time to look it up in the unit circle, cosine is x over r is always 1. It'd be root 3 over 2. Now let's square. Root 3 squared is just 3. 2 squared is a 4. 1 squared is just a 1. 2 squared is a 4. 3 over 4 plus 1 over 4 is 4 over 4, which, yes, equals 1. It will work for any angle ever. That is what a trig identity is. Now, you might be thinking, well, they just found this for fun, or because that mathematician had nothing better to do on Friday night because he never had a date. But there's bigger uses, and there's quite a deep level of studying you can do. Now, the final thing that we'll do before we start the first of your areas of study is non-permissible values. And that would be number 1B in the PDF notes. I'll just abbreviate it. We know this already. A non-permissible value is saying, what are you not allowed to put in for x? So in this case, x can never ever equal 3 because you're dividing by 0. Even though we don't have to go there, graphically it would mean there's an asymptote. And so then, you never cross a vertical asymptote, you never touch it. That would be what again is called a non-permissible value. You can also do it in trigonometry. You can also do it in these guys. So I know that I didn't write down cotangent equals this, but let's say I just said to you, what are the non-permissible values? What could x not be? Here is where, for the first time, you start to realize, oh, the graphs of sine and cosine, they're pretty to do, but man, are they useful. We could figure out what is x not allowed to be using the graph of sine. So we are never ever allowed to divide by 0. How many times is sine 0? Well, it'd be infinitely many, but we could at least say some of them and then just go ... to say them. Right here at 0, right here at 180, and right here at 360 are 3 of the most common ones. That would be, like what we usually write down as 1 period of sine. In radians, it'd be 0, pi, and 2 pi. And then it would keep going forever, forward and backward. There'd be infinitely many non-permissible values to that expression. Now, as we move to then the first big thing, I am going to do my third kind of warning of the day for you guys. When we were working in chapter 6, it really requires drill and practice. You have to do many questions, then you start to see it. And I will again tell you guys, just like almost anything in math, the first time you see something, it feels a little uncomfortable, but then the more you practice, it gets better. That is going to be probably at its most truest form right now. When you're working in chapter 6, when you start any idea, it really is like, whoa, like what it really is going on. But with practice, it becomes more and more comfortable. So make sure you guys practice. So here's how we're going to move to the final part of today. We're going to do a series of examples, and it will seem very strange, but if you fight your way through, it will come to you. The very first thing that we're going to do with these identities is we're going to look at, well, how could you simplify? So you'd be given an expression, and then you'd be using those first 8 identities on page 296 to simplify. Now, we already know simplify. We've been doing it forever. It means to take something big and bring it really small down to just one thing. The only questions I'll assign to you guys are ones that go down to one thing. So here is the very first example in the PDF notes. It says cosecant x, and then it goes sine x, and it says simplify. And you might be like, what am I supposed to do? Isn't that as simple as I can get? No. There is always something that you can do to make it smaller, and I promise you I'll only give you questions that go down to just kind of one term or one number. Now, here's how you could do this one, and you probably wouldn't have seen this coming without a bit of prompting. Cosecant is actually 1 over sine, and sine, I'm just going to leave it alone. If you wanted to, you could write it over 1. Now, one of my favorite things in the world ever to do is to cross out, because there's a sign on top and bottom, they go away, and this essentially simplifies to just 1. That is what is called simplifying a trig identity. Let's do another one right away. It does take time and it does take practice to kind of get used to these ideas. So the next question, that doesn't have brackets, but I'll put them in just to get us started anyway, says, what would cosine times cosecant simplify to? So that's the question. Now, I'm going to leave the cosine alone. I'm going to take the cosecant and write 1 over sine. Now, unfortunately, nothing cancels out, but you could just multiply straight across. Cosine times 1 is cosine x, and then 1 times sine is sine x. Now, if you guys dart your eyes at the identities, cosine over sine is cotangent x. That's been proven many times over. That is what is called, again, simplifying a trig equation. Now, something interesting happens here. These would be like very easy entry-level problems. Sometimes when it's too easy, you don't really get a feel for what the heck is going on by this word simplify. So I think the next few examples start to get it a little bit better. In letter C, the question is cosine x multiplied by tan x and then multiplied by cosecant x. X is just the the variable, the angle symbol if you want. Often the textbook uses theta. It has to be there, but don't panic. Now, you look at this, and then it maybe becomes a bit more obvious. This is a little bit of a larger expression that we have to suck down to just one thing. And so then here's how we're going to begin. Okay, we're just going to leave this cosine x alone. And then the tangent x, we're going to change to sine over cosine. And then cosecant, we're going to change to 1 over sine. Now, first thing that I'm going to tell you guys, don't panic. In your head, you should be like, well, I wouldn't have seen to do that. How are you supposed to know that? The more you do, the more you realize what to do, the more patterns you see, and we will write them down. Today, we're just going to try to experience them, and as we keep going through this chapter, we will be writing down these things as hints. So don't panic that way. I'm just trying to give you guys the idea of what it is. So we're going to leave this cosine alone, and it could be thought of as over 1. And now when you guys take a look, oh, this is very much like before, because everything is multiplied together. You can cross out the cosines, 1 on top, 1 on bottom, the sines, 1 is in the numerator, 1 is in the denominator, and what are you left with? Just a 1. Now, second last example. The second last example, I need the full board. This one requires a little bit of manipulation of one of the identities. For example D, in your PDF version of the notes, you have 1 minus sine squared divided by cosine, and the question says, simplify this. Make it as small as you possibly can. And you might be like, ooh, I was kind of liking A, B, and C a bit better, even though I didn't see what to do. They made a little bit of sense. What I need to do is just a little bit of side swipe, and maybe I'll do this in red, so it doesn't look like it's part of the blue answer. And what you see in the PDF notes is kind of like a little arrow. This is like an off to the side. Sometimes I call this my do not write down zone. This one I would have told the students to write down. Now, we go to the very first of the Pythagorean identities, that cosine squared plus sine squared equals 1. And what if I just said to you guys, only look at the red, cover everything else up, and just let's look right in here. What if I said to you guys, for some random reason, take this sine squared over? Well, it's a plus now. To bring it over, you'd have 1 minus sine squared. Now, this is where you really have to think. As soon as you spot it, it's a very easy idea, but some people kind of daydream through it and then they don't see what I'm trying to tell them. Right in here, cosine squared is equal to 1 minus sine squared. Another way to say that is cosine squared, you could replace it by 1 minus sine squared. I haven't done anything wrong. This is a true identity. Subtracting that over is not breaking any rules of math. Cosine squared is equal to this. It's replaceable by it. Now, here's then how this solution could go, and you weren't supposed to see this coming. The question has 1 minus sine squared divided by cosine. 1 minus sine squared is equal or replaceable by cosine squared. Now here's what we can then do. If cosine squared really means cosine times cosine, because everything is multiplied together, we can do my old favorite, cross out, and you are left with just cosine. And then this is not cheating. In simplifying, you always want to show every one of your steps. I like to work in a downwards fashion. I would encourage you guys to do it. Put an equal sign at every step. You could do it like this. If you really understand what this means, you could take this square and this out, and that's the same as this step. That is not cheating. That is not skipping steps, because you'll need to show all of your steps to receive full marks. Now, when you see that one, then you're going to start to get a feel for things with our last example. In our last example, what you have is 1 plus tangent squared x over top of cosecant squared x. Now, don't write this down. We will have this further on in the PDF notes. As we gain experience, there's certain things that are going to be almost like little hints. They're coming off the page and kind of, slapping you in the face. Sometimes when you look at something, you're going to think, maybe I should try to turn everything into sine and cosine. When you see ones and squares, you're going to be wondering, I wonder if I should look at the Pythagorean identities. And that is really going to be a truism. It'll often be something that leads you down a good path. Now, 1 plus tan squared. What I want you to do is, again, take your eyes right to page 296, the Pythagorean identities. 1 plus tangent squared is equal to secant squared. And so it can be replaced by secant squared. And so we're starting to make it smaller. Now, at this moment, you are not supposed to know exactly what to do. You are normal if you look at this and then you're left wondering, well, how am I going to take it even further? Can I even take it further? This is where the experience comes in, both from watching my lessons and then doing questions on your own. So here's what you could actually do. Just pretend for a moment the squares aren't there. I'll bring them back in a moment. Secant. Secant is 1 over cosine. That's its reciprocal. Cosine is 1 over sine. What else are you going to do? Now, dividing one fraction by another, well, you flip. Keep, change, flip. This would be 1 over cosine multiplied by sine over 1. We're flipping it up. I'm just going to continue it up here because I'm out of room. What would this equal? Well, this is just sine over cosine. Wait a minute, what is sine over cosine? If you look at the middle identities, the quotient identities, that is tangent. And so then you're starting to realize, oh, simplifying means to take something large and using the identities, it's almost like a puzzle, you can take yourself down to just one thing. Now, let me bring the square back in. And no, you don't have to change to red if you're color coding with me. The square doesn't go away, but you don't even have to worry about it. It just stays the whole time. Each of these was squared. And then this, you'll feel like you always knew it, even though you haven't. If you have sine over cosine, it's tangent. If you have sine squared over cosine squared, it is tangent squared. The power just stays. And that is what simplifying is. Now, I know this was a long lesson, but I have some advice to give you. The first 8 identities, the ones that you see on page 296, it is in your best interest to memorize them. I'm not kidding. Even though they're always given to you, you will always have them in front of you, and not just right now that we are working from home. Even in a regular class setting, they would always be given to you. I would memorize them. The more we do, the more you get used to these patterns, the more you start to be like, oh, I think I'm going to change this to 1 over cosine. We will write those down. But seriously, it's like a giant puzzle where sometimes if you just get started, then things start to unfold. Once you've memorized these identities, then you really start to see the patterns, and you'll never truly be good at chapter 6 until you do. That would actually be the first thing I do. I would look at page 296. I would write the identities down a bunch of times, and then I would begin the assignment, and it'll go quick. Probably 5 out of the 8 identities, maybe even 6 out of the 8, you probably have memorized right now.